So I have a problem. Well, I have many problems, but the one we're going to be talking about today is to do with my love of old PCs. Obviously that's not a problem in itself, but with some of them being over 40 years old, parts of them have degraded over time. This is especially true for keyboards, where I've had my disgusting sweaty mitts all over them. And mice are even worse. If you haven't used an old ball mouse recently, then you've probably forgotten how rubbish they were new, let alone after 30 years of decay. My problem is, therefore, that I'm running out of working keyboards and mice for my retro computers. Wouldn't it be nice if we could plug fresh new keyboards and optical mice into these old computers? Well, I thought so too, so I designed this open source adapter. It's called the HIDman, and it allows you to connect modern USB input devices up to nearly any retro PC. Let's get into it. This video is brought to you by PCBWay, more about them later. Now, this being my channel, I'm going to go into a fair amount of detail about HIDman's design and assembly, so if you don't care about the technical stuff and just want an overview of the features and a user guide, then skip to blah blah blah. For the rest of you, let's start at the beginning. Regular viewers will know that a couple of years back I got really into building tiny MS-DOS gaming PCs. I wanted one of these PCs in my living room, so naturally it needs a wireless keyboard and mouse. But the snag is, these PCs only work properly with PS2 keyboards and mice, and good luck finding a wireless PS2 keyboard or mouse in this day and age. And even when they were available, they tended to be pretty terrible. This is about the best setup I could find on eBay, and while the keyboard is okay-ish, the mouse weighs 1,000,000 tons and is incredibly unresponsive. So I got to thinking, both USB and PS2 protocols are pretty well documented. How hard can it possibly be to design an active adapter? So I drew up a vague list of requirements. First and foremost is simplicity. I wanted HIDman to be very much a set and forget type experience, as messing with old PCs already involves a lot of fiddling, so the last thing you want to do is spend ages setting up your bloody keyboard. So the device should just work when you plug it in, with no need to wade through configuration files or install drivers, etc. I also wanted it to be relatively cheap, so that means cutting down the number of components to a bare minimum, as well as using a lower spec microcontroller. I also really wanted it to have 2 USB ports, as, well, obviously you need a keyboard and a mouse, so it's a no-brainer really. I know wireless dongles only take up one port, but I plan to use this thing for desktop PCs as well, and having 2 ports opens up the possibility of other USB devices like game controllers and whatnot. And finally, I wanted it to support early 80s PCs, as peripherals for those are even rarer, so it had to have serial mouse support, as well as the weird keyboard protocols that were often used in PCs from that time period. Now, you might be aware of the USB for VC by Deku Nukem, which is based around a Raspberry Pi and is a fantastic device that does basically everything I mentioned here and more. It's also open source, so you might be wondering why I didn't just build one of those. Well, as it's designed to support many computers besides PCs, the setup is highly modular and requires at a minimum 3 separate PCBs. I wanted something far simpler that was entirely self-contained, not to mention smaller and cheaper. That said, there is a very good reason why the USB 4VC needs such a powerful computer, but I'm getting ahead of myself. So, what processor would be more suitable? Another popular option is the RP2040, also known as the Raspberry Pi Pico. This is used in another excellent USB to PS2 project, the PS2x2 Pico by no one, and is certainly more like what I want. It's a good deal cheaper and smaller than a full-size Raspberry Pi, and has a very flexible programmable I/O peripheral that can actually be used to run extra USB ports. But the RP2040 does have a few quirks that make me dislike it for this application, such as no built-in flash storage and slightly awkward power supply requirements. In addition, its GPIO ports aren't 5V tolerant, so some voltage level translation components would be required to interface with the 5V logic levels of older PCs. So I decided against the Pico, mainly based on the number of additional components required to support it. So what does that leave us with? Well, IC manufacturer WCH has a very interesting selection of chips, in particular one called the CH559, which is an 8-bit microcontroller that costs just over $1, runs off a single 5V supply, has a reasonable amount of flash memory and RAM, 5V tolerant GPIO, and best of all, 2 fully functioning USB host ports. This seemed like an ideal option, so I grabbed one of their very reasonably priced dev kits and got to work experimenting. The CH559 is based around the venerable Intel 8051 processor, which actually predates the original IBM PC, so I can fool myself into thinking it's not anachronistic. The official CH559 code examples are written for the commercial Kyle C compiler, but that didn't seem appropriate for an open source project, so I managed to port it over to the open source SDCC compiler with very little hassle. Initial experiments using the WCH example code were very promising, as it accepted most USB devices, and the USB HID protocol looked simple enough. So I started working on what I assumed would be the hardest part of the project, which is is the PC interface. I started with the PS2 protocol, which is what I assume most people will be using. Electrically speaking, it's pretty simple and not a million miles away from the I2C standard that a lot of you will be familiar with, except the keyboard is the master and the PC is the slave. There are two signals, clock and data, which are driven in an open drain fashion with pull-up resistors to 5 volts. This is what allows us to interface with the 5 volt logic levels of the PC, despite the CH559 being a 3.3 volt device. The higher level parts of the PS2 protocol are a little more complicated, and not really much like I2C at all. I found this article from computerengineering.org extremely helpful, as it pretty much explains everything, but I also found a lot of utility in looking at keyboard logs and a logic analyzer to understand edge cases a bit better. The logic around inhibits and transmission retries was quite tricky to get right, and of course different PCs behave in different ways, because why wouldn't they? The PS2 protocol is a little too weird to be able to use any of the built-in communication peripherals in the CH559, but since PS2 only runs at about 15 kHz, we can easily just bit-bang it. I coded up a simple state machine that runs on a 60 kHz interrupt and is fed from a ring buffer. It's not the most elegant thing in the world, but it works fine. The older XT protocol is actually pretty similar to PS2, but it's just different enough that I ended up writing a separate state machine just to keep things simple and performant. Serial mice are easier to deal with. We just need the old faithful MAX232 chip to do the voltage level conversion. Software-wise, the CH559 has a built-in UART peripheral, which makes sending serial data as easy as poking a few registers. So, job done, right? Well, when testing, I often noticed that some features of certain USB devices didn't work, like the scroll wheel or middle mouse button on many mice. Worse still, different USB devices seem to be giving out completely different data. People unlucky enough to be familiar with the USB HID protocol will know exactly why this is, and why the USB part of this project turned out to be the most complicated after all. Prepare to enter the murky world of HID report descriptors. This is sort of like a map that describes the semantic meaning of each and every bit in the report. The format of this descriptor is rather vaguely defined in the device class definition for human interface devices, which goes into somewhat less detail than I'd like. There are some open source HID report parsers available, but none of them were suitable for an 8-bit processor with 6 kilobytes of RAM. As I hinted at earlier, this is probably why the USB 4 VC went with the Raspberry Pi as a base, as it can run Linux, which has a very well-tested HID report parser. So with no other options, I just had to roll my own parser. I'm not massively proud of it, and it's in the middle of being refactored, but it seems to work under most circumstances. With the firmware more or less working, I needed a way to test that HIDman was sending the correct scan codes. There are a few keyboard testing programs available, but the ones for 8088 PCs didn't support all the keys that modern keyboards might have, so I wrote my own keyboard testing program. It runs in real mode, so it should work on any PC that can run DOS, and it can read keys via the BIOS as well as directly from the keyboard controller, which is helpful as older BIOSes don't support all keys. It knows about every key scan code, including all the language-specific keys, the rarely seen function keys F13 to F24, as well as the media control and web navigation keys you sometimes see. Source code for that is available too. You'll need Turbo C to compile it. The last thing to do is design the hardware. It's always important to design your circuit board around the enclosure you plan to use, rather than finding an enclosure to fit your already designed board. Although you might be able to get away with it if you're designing your own 3D printed case, I prefer using extruded aluminium enclosures, which are only available in certain sizes. It does however help to lay out the connectors in your PCB design program so you have a rough idea of how big the enclosure will need to be. Then you have the joy of searching for hours through manufacturer catalogues until you find one that's about the right size. For the early prototypes, I used this case from Hammond Manufacturing, which I think looks really slick, but unfortunately it's quite expensive and there isn't enough space for the serial port, which is really necessary if we want to support older computers. Instead, I went for this nice looking one from Lincoln Bins, which is big enough for a serial port as well as being much cheaper. The datasheet for it tells you exactly how big the circuit board needs to be, so I laid that out in KiCad, my PCB program of choice, and finally got down to the business of designing the board. Once that was done, I needed to design end plates for the enclosure. Traditionally, these would be custom milled from aluminium and painted or silkscreened, which costs a fortune. However, one of the favourite tricks I learned from Mike Harrison of Mike's Electric Stuff is to make them out of PCBs. They're perfectly strong enough for our purposes, and they have all the custom holes and high quality printing we could ever want. And they cost less than $1 each. So that's about it for the technical discussion. Now you might be wondering where you can get a HIDman. Well, option 1 is build one yourself. It's all open source, so you can grab the Gerber files and parts list from GitHub. One guy called Dubezenhauer has already built one on Livestream. I'll give you a link to it below, it's a really good overview of the process. If you're not up for building one, then I might have a few ready assembled ones for sale. Check the video description for more details. Price is about $100 depending on which cables and adapters you want included. In the likely event that I'm sold out though, you can get my sponsor PCBWay to build you one. They're actually who I got to build mine, and they did fantastic work. I paid my own money for them, so you know I'm telling the truth. I've uploaded the design files to PCBWay's shared projects section, so all you have to do is select PCB plus assembly and click add to cart. Then select the quantity you want. You have to buy a minimum of 5 bare circuit boards, but you only have to have one of them assembled if that's all you need. Then you also have to buy the end plates for the enclosure. There's no assembly this time, but you'll probably want to tweak some of the options. To start with, I'd recommend setting the thickness of the plate to 1mm, and set the colour to whatever you'd like. I made mine black, but I think blue would look quite nice too, a bit like what I did for my WC project. Totally up to you though. If you want to make the front plate yellow and the rear plate purple, then go nuts. Then finally, as you're going to be touching the enclosure, I'd advise selecting one of the lead-free finish options, like Hassel lead-free or even Immersion Gold if you're feeling fancy. Then save to cart. Don't forget to order the rear plate too. While you're at it, if you need any 3D printing, CNC machining, sheet metal fabrication, or even injection molding services, then definitely give PCBWay a shout. I've been using them for years in both my personal life and in my day job, and they've never let me down once. Their customer service and communications are excellent, and the work they do is absolutely top-notch. They're also doing their 7th annual PCBWay design contest, where you can win up to $1,500 cash, as well as a cute robot dog. So if you have a design you're proud of, then upload it to their Saved Project section and maybe win some great prizes. Anyway, as well as the PCBs, you'll also need some other bits and pieces. The enclosure I bought is the 40mm E-Case A from Lincoln Bins in the UK. Don't forget to order screws with it. If you're not in the UK, you might be able to find the same case under a different name elsewhere. Or if you have a 3D printer and are feeling cheeky, you could download the step file from Lincoln Bins and print it yourself. You'll also need some male-to-male PS2 cables and a USB A-to-A cable for programming the firmware. If you have an older PC, you may also need a PS2 to AT adapter for the keyboard and a straight wired, i.e. extension, serial cable. Maybe even a 25 to 9-pin serial adapter if you only have 25-pin serial ports on your PC. Anyway, now we have all the parts we need, assembling it is as simple as screwing everything together and flashing the firmware. I'll give a brief overview of flashing the firmware here, but the instructions are also on GitHub if you want more detail. First, download and install the required software on a non-retro PC. If you're on Windows, grab WCH's official programming tool, the link is in the video description. Linux and Mac users have a few options, but the only one I could get to work was CH55X tool, which also requires Python to be installed. You'll also have to download the firmware. Latest version will be in the releases section of the HIDman GitHub. You're probably best to grab the bin file as it can be programmed on Windows, Mac and Linux. But either way, next step is to use a USB A-to-A cable to plug HIDman's lower USB port into a USB port on your non-retro computer whilst holding HIDman's button down. You have to hold the button down to switch it into programming mode. Then, if you're on Windows, fire up WCH ISP Studio. It should automatically detect the CH559 and bring up this window. Then just follow the instructions on this screen. Mac and Linux users will need to invoke the ch55x tool.py with the -f option and specify the name of the firmware file. That should be it. Now, let's get started using the thing. Let's start with the most basic setup. You have a USB keyboard and mouse, or perhaps a combined keyboard-mouse wireless dongle, which you want to connect to an old computer that has PS2 ports. This should be pretty self-explanatory. Connect the keyboard and mouse to HIDman's USB ports, connect the PS2 ports marked mouse and keyboard on HIDman to the equivalent ports on your PC, and switch it on. The power light on HIDman should light up bright blue, indicating it's set to PS2 mode. If it isn't bright blue, press the button on the front to cycle through different colours until it is. That should be it. You should now be able to use your mouse and keyboard just like normal. If you're using DOS, I recommend using the Qt mouse driver for mice, but Windows will be able to figure everything out by itself. For older style keyboard sockets with the larger 5-pin DIN connector, you can use a widely available passive adapter and it'll just work. Then for mice, you can just use a normal male-to-female serial cable to hook up to the PC's serial port. Again, I recommend Qt mouse as a driver, as it seems to work fine even on 8088 PCs. For really old PCs, you might have to set the keyboard mode to XT by pressing HIDman's button until the light turns orange. That should cover the original IBM PC and XT, as well as clones by other manufacturers. HIDman even supports Amstrad's range of cheap and cheerful plastic machines, which I'm very fond of, but you'll have to build a little adapter like this. To select Amstrad mode, make the power light white. The choice of colours might seem a little bit odd, but I think they should be suitable for people with colour vision deficiency. I actually checked these with someone who has colour vision deficiency, so shout out to my mate Tom if he's watching. I hope to add other non-standard keyboard protocols in the near future. So, hopefully you now have a working HIDman. You might however want to change some configuration settings, and that's done through a built-in menu system. To access the menu, bring up a text editor on your PC. It doesn't matter which one. If you're an MS-DOS, then Edit is probably a good shout, or Edlin if you have an older version of DOS. Windows users can do Notepad, and Linux users should probably use Nano. Make sure the editor is ready to type, and hold HIDman's button for a few seconds until text starts appearing. This is the menu. In the keyboard and mouse menus, the advanced USB options enable full HID report parsing, which might enable extra features like N-key rollover on keyboards, or the scroll wheel and middle mouse button on mice. These are disabled by default because they can cause problems, but if you want those extra features, then by all means turn them on. IntelliMouse enables the scroll wheel on the PS2 port and also the third mouse button. Press Escape to exit the menu. If you have problems with HIDman, then there are a few ways to diagnose things. You notice that when you press the keys on the keyboard or move the mouse, HIDman's power light blinks. This means that USB connectivity is working, and if you're having problems, it's likely to do with the connection to the PC. Check that HIDman is in the correct mode and that you've connected everything to the right ports. On the other hand, if the power light doesn't blink, then there is an issue with the USB connection. Maybe your USB devices are too complicated for HIDman to understand. Try a different combination of devices and see if those work. If you do find a device that just doesn't work at all, then you can help the development of HIDman by sending me a HID dump. You do this from the menu. Start with the offending device disconnected. If it's a keyboard that's not working, then you'll have to find another compatible keyboard in the meantime just to navigate the menu system. Go into the menu, select Advanced, then Log HID Data. Then plug in the offending device and it'll dump a lot of gibberish to the screen. After several seconds, when it seems to have calmed down, perform a few actions on the device, i.e. press a few random keys or mouse buttons. Hopefully you'll see some additional gibberish. Once you've done that, hit Escape on the keyboard, that is the one you used to navigate the menu originally, and save the text file you just made to disk. Then either send the file to me, my email address is in my YouTube profile, or head to the HIDman GitHub, create an issue, and attach or paste the file contents into it. Note that I don't guarantee I'll get HIDman working on every combination of devices. In fact, certain USB hubs are buggy, and there's nothing I can really do about that. But if you have a relatively simple setup that you think ought to work, then please get in touch and I'll see what I can do about supporting it in a future firmware version. Warning though, if you can't get it working with your solid gold 1000-watt RGB emoji keyboard with 100-port USB hub and heated codpiece, then my advice to you is maybe consider getting a $10 Amazon Basics keyboard. With that out of the way, let's talk about some more advanced setups. Perhaps the most fun one is USB game controller support. This feature should still be considered in an early state, but it does work pretty well on compatible game controllers. Basically, how it works is it maps the various buttons and sticks on a game controller onto keyboard and mouse actions. This allows you to use a game controller to play games that only ever had keyboard or mouse support. By default, it will only emulate a keyboard, but you can turn the right analog stick into a mouse by enabling Use as Mouse in the game controller menu. The right analog stick will control the mouse pointer. The shoulder buttons then also become mouse buttons. This works great in first-person shooters like Doom and Quake, and you can even use one to navigate Windows if you like. There are some caveats, however. The first is that Xbox controllers use a proprietary protocol, so they won't work with HIDman. PlayStation 4 and 5 controllers do work, however, as do most PlayStation to USB adapters that take PS1 and PS2 controllers. I think PS3 controllers should work too, but I haven't tested them. These cheapo SNES-style USB controllers work great too, although they do feel like crap. Let's talk about more advanced setups. Many devices such as mini PCs and laptops only have a single PS2 port that does both keyboard and mouse at the same time. You're supposed to use a passive splitter like this one to be able to connect both at once. However, with HIDman, you don't need any such splitter. Just use a single PS2 cable and you're golden. Generally, mini PCs will need to be hooked to the HIDman's keyboard port, and laptops will want the mouse port. But if one port doesn't work, just try the other one. You won't break your PC doing this. Another way to take advantage of this functionality is to use a passive splitter on HIDman's outputs themselves. This allows you to hook up a regular PC with 2 PS2 ports to only one of HIDman's outputs, keeping things a bit neater. If you were annoyed at the fact that HIDman's mouse port is at the front, this allows you to keep all the cables at the rear. Okay, I think that's about covered everything, but it wouldn't be my channel without some mad experiments. You see, you can actually buy devices that are sort of the opposite of HIDman. They convert PS2 to USB. I've actually been using one to test HIDman without having to have an old computer hooked up. But if you're anything like me, you'll have already had this intrusive thought. As you might expect, it just repeats whatever you last typed in over and over again. It was pretty funny. Alright, well how about this? Here I have a delightful Comic Sans USB keyboard, which I've plugged into a HIDman, which is plugged into a USB converter, which is plugged into a HIDman, plugged into a USB converter, plugged into a HIDman, plugged into a USB converter, plugged into a HIDman, then finally connected to a PC. And as you can see, it works perfectly. There isn't even any noticeable lag. Alright, this is starting to get silly, so let's wrap up the video. I'd like to end by showing some of the projects other people have done with HIDman as a base. First, there's Sarasman, who's built a smaller version called the HIDman Mini, which has hardwired PS2 and serial cables, making it much more streamlined. There's also his HIDman Micro, which plugs directly into a PS2 port. I'd love to make these the default form factor for HIDman, but they're a bit too difficult to assemble. If you fancy building one yourself though, then the link is in the video description. Florian3 designed a HIDman variant that mounts directly inside the PC's case, making an even more streamlined setup. Maybe it would be cool to take this concept further and design a card that mounted to a bracket and provided external USB ports. Finally, there's this person, I won't try to pronounce his name because I keep getting it wrong, who designed the Tiny Llama mini DOS gaming PC that's sort of a spiritual successor to my Wii C project. The Tiny Llama uses the HIDman chip to do USB to PS2 conversion, as the built-in USB support gets pretty crashy under DOS. It's a super cool project, and the third version is currently under development, which has an MXM slot for external graphics cards. It pairs perfectly with SDZ's Voodoo 4 MXM card, which is another incredible project I just found out about. Links to everything is in the video description. Okay, this video has gotten long enough. I'd like to say thanks to everyone who's contributed to HIDman so far. These people contributed directly, also anyone who's sent in HID dumps for debugging. There are still a lot of features I want to add, so if you fancy helping with development, then check out GitHub. I'd also like to say thanks to Clinton for donating me an IBM 5150. The main reason I got it is for testing HIDman, and I still owe him a couple of HIDmen, so I should probably get around to sending those. Anyway, thanks for watching this video, and if you have any questions or suggestions, then leave a comment and I'll do my best to reply. Like and subscribe, etc., and I'll catch you for the next video.